So today I'll explain a bit. These are packages that I made called sgejobs. I made it last year because I was dealing with a lot of like files and stuff, and it's kind of like the culmination of a system, I guess, that I've been working on for like a very long time. There's actually like like during my PhD, I was working on a project that involved like a lot of bash scripts and stuff like that. And so if you go to github.com, lead group, their supplement, you'll notice here that there's a lot of like shell scripts and R scripts tied to each other. And like these shell scripts are like made such that, for example, if I go to these make models here, it's like built as a small pipeline such that like this shell script will only run if the previous script has finished running using this hold JID flag. And so this repository, I guess, was last updated like 5 years ago, really. A lot of these codes. And some of the code that I use here was actually started by like another PhD student working with Jeff Leak. Her name is Elisa Frazee. And so this, set of writing scripts and stuff is something I've done for a while, but every time I had to do them manually. And so that's where this package comes in, because I was like, okay, maybe I can make a little R package that will help me make all these scripts and basically make me more efficient when I'm working with Sun Grid Engine or Son of Grid Engine system, which is the type of cluster system that we have at JHPCE, which is the main cluster we use. And so because a lot of you are working on this cluster or will potentially be working on this cluster, I thought it could be useful for you. So if you actually want to install this package, it's only available through GitHub. So you need to install it with like remotes install GitHub Libre Institute /sgejobs. And even though this is a GitHub only package, because I thought like there was maybe not a lot of point in sharing this package with Biconductor, because it's kind of really specific to JHPCE or like CRAN, for example. It does have like a full documentation. So if you go under articles, there's an introduction to the package, which is what I want to walk through right now a bit. Okay. So like a lot of my packages, I have a section at the top about like asking for help, how to cite it, and things you might need to know before. So, I mean, all of you are, I think, JHPCE users. Let's just get right into it. So the idea of this package is that you use this directly on JHPCE. If you load it, let's say you want to, you're working on an R script and you want to create a bash script for it that you can then submit to the job, submit to the cluster, and that will run your R script, right? So that is like the most common scenario. And for that, I wrote a function called job_single. It's single because you're only doing like a single task at a time. And so the way that you would do this is you run the function job_single. You give it a name, which is the name that's going to be used by JHPCE for describing your job. It shouldn't have any spaces or anything like that. So that's why I'm using an underscore here. And you could potentially also create the logs output directory, and which is set to true by default, but here I'm like, in this example, again, I set it to false. So what will this do? So this actually creates a bash script for you that has all the configuration you need to then submit it to the cluster. Let me actually run this on live. All right, so 2 gigabytes of RAM does the job. So here I get a message saying like, oh, I already have it installed. But if I wanted to force a reinstallation of it, I could use the force equals true argument. But anyway, at that point, I can now load sgejobs. And I can create now a specific example. So when I say like job single, just gonna call it example underscore 01 defaults. So what did this do, right? So it's printing a lot of information for me on the screen. But if I go to, let's say, CyberDoc, just explore what I have on my computer, I mean on Gypsy at this point. So you'll notice here, it created a directory called logs for me, which is empty. And then, yeah, I guess that's it. It just printed the message itself. So let me make this test a little bit better. So I'm going to delete that directory there. Right. So let me run now again my example of example 01 defaults. That will make things a little bit cleaner to see. Okay, so right now there, it only created the logs directory. It's empty, and it didn't create anything else. But this information here, like maybe that's all I need now to then copy paste into an R script. Or that maybe, maybe that's a little bit too much. So let me go see the exact help page for job single. And you'll notice that there's the second argument is create shell, and the default is false. Let me change it to true. And so now it doesn't actually print all the information. It just says that it created the logs directory and that it created the file example underscore 01 defaults.sh. And then it's even giving you the command if you actually want to run that. And so that would be key sub example 01 defaults.sh. So if I refresh this window now, I'll notice that I have that shell script now. So what is the structure of this shell script? So it includes already a lot of the configuration options that you need for running code at Gypsy. So we're using SunGrid Engine, and so a lot of the options for SunGrid Engine are specified by the $$ syntax. So lines 2 to 7 are options for SunGrid Engine. One of them is that we want to run our code on the current working directory, which is CWD as an acronym. Here we're specifying the list of resources that we want. So in this case, I'm saying I want 10 gigabytes of RAM to be free with a maximum size of 10 gigabytes to use. These two numbers, they should match. That's part of the instructions that you get when you learn about how to use JHPCE. This other option over here is like setting the maximum file size. And so I want to be like, oh, 100 gigabytes. The name of this job specified by the -N argument is example_01_defaults. And you'll notice that like not having any spaces was important because now I'm setting the log output files, the standard output and the standard error one, to be logs/example01, etc. .txt. I like to use the .txt extension because these are really like text files, and then a lot of software will recognize the .txt extension and be able to load it. If you use like the default like .log extension, then like some of the software doesn't know how to handle it. Then I'm setting the -m option, which is like when do I want to get an email, and I set it to E, which is I want to get an email when the job ends. Now let's say the job actually starts running. So I always like to print the date of when my job started. This is useful if I see a log file in the future, and I want to, the date can be useful. I also want to have information about who actually ran the job. So like, who's the user, what was the job ID, what was the name of the job, what computer he ran on. There's a lot of computers on the cluster, and sometimes they have weird behaviors. And this one in particular is useful if we were running a parallel an array job, which is not the case here, so it will be empty. After that, I'm like, okay, I'm gonna use some of the configuration values that maybe some of us have on our bash RC files. But here I wanna say like, okay, I wanna load R, and you can change this. You can be like, oh, actually, instead of loading the default R, maybe I wanna load like the latest like 4.x R instead of the default R, which is 4 right now. But because a lot of us have like different configurations and stuff, I run the module list command to show what are all the modules that we have loaded, and this can be useful for reproducibility. Then here, there's some instructions like, okay, you might want to edit line 26 with your actual command of what you want to run. So this is just a very quick example that says, it has an R command that says like, let's set the options to 100, the width to 120 characters, and then print the session information. Then at the end, I'm like, okay, this is, the end of the job. And so this is something that I've done a lot of, that I used to do like by copy pasting a previous shell script that I had made in the past. And then I will need to like manually update the name, the log files, etc. So I see that there's a question by Maddie.
Why do you use a default screen width of 120? Is there a specific reason?
So I like to set it to 120 characters when I'm printing the output of session info, because if you have packages that were installed through GitHub, you need more space, more column space. So for example, if I just run that command right now here, oh, actually in this case it was not the best example because I guess I had enough space to show this type of GitHub information, right? But sometimes it can get really long, and you need a couple more characters. But this is just really an example, line 26. You can edit it with whatever you want. So that's the output of this. And so maybe like if you're a SunGrid engine user, you might be familiar with all these options and stuff. So sgejobs is actually like an interface for this. And so if you look at all the arguments that it has, we'll notice that it has R arguments for specifying a lot of these options. So you can specify what queue you want. So whether you're using the shared queue, or for example, if we're talking about our Libre nodes, then that would be the BlueJ queue. You can specify how much memory you want. So here I'm saying like 10 gigabytes. You know, this memory argument is a lot easier to understand than, let's say, mem_free and h_vmem, right? The number of cores that you're going to run if you're going to use something in parallel. What are the email options? That's easier to remember than -m, for example. What is the file size that you're going to, you know, the maximum file size? So that is like h_f size. There's an example command here. So, I mean, you could actually, you could even like, from R, you could even specify the contents of line 26. But I typically just run the command, run the job_single command, and then open the text file and then edit it. So for example, let's say that I had a script here called test.r, right? I would just edit the contents of line 26. And then just say like R script test.r, right? One of the common errors is like if you're using a directory for saving your log files, such as here logs. If you don't actually create the logs file and then you try to submit your job, you submit the qsub bash script. If you then run like qstat, it's just gonna show that the job is hanging, right? And you're gonna be like, oh, I don't actually get an error message, what's happening? And this has happened to me like countless of times, and it's just like, I forgot to create the logs directory, right? So that's why this like create log dir option is set to true by default. Right. So that's how you can create a regular job, right? Now, there's more advanced settings with subgrade engine. One of them is running parallel jobs. So you can specify that your job requires, for example, 10 cores, right? What is this going to do? On the output script, it's going to add the PE local subgrade engine option and specify like the number of cores that you actually specify, right? So this can be useful. You don't want to remember the specific syntax for, you know, for running stuff in parallel. You could say that that's like a fairly small edit, right? You might like just run it by default and then over here manually edit and let's say like, you know, P local 10, right? That could be, you know, all you need to do, right? To make it parallel. Another thing is you might want to make your job parallel. Sorry, not parallel. You want to make it into an array job. What is an array job? So that's a bit more complicated. An array job is when you have the same code that you want to run across a set of inputs. So this is actually going to involve you running a more specific R script. So let's say you have an R script that takes an input argument. And so you might want to do something like this. Or you have an R script that takes multiple inputs. And it's going to do something very specific for each of them. So one common scenario is like, let's say we created like, we have a set of like input files, right? And we want to do the same task for each of those input files. So let's say we want to align them. We have a lot of like FASTQ files and we want to align them, right? So we could just use this type of syntax. Or let's say we have an R script that is working with like one gene at a time. And so this could be like input gene, for example. Like the other script was like, let's say like a high sat here, like right, that could be like the syntax for it. I mean, the true command will be a bit more complicated than that. So that's what you need to do from the R side and stuff. But from the SunGrid engine side, you specify the task number here on job single. What it does is that it adds the next set of options, -T and -TC. -T here is for specifying that you're running a job across 20 tasks. That's what we specified as a task number. -TC here is the maximum number of concurrent tasks that can be run. So that's where this argument comes from. The job, the log files also change. So now the output logs have this $task_ID environment variable that's going to change between like all the tasks. And so this, is jobs_single is probably the main function of the package, SGE jobs that you're going to be using. There's a couple more advanced functions. And so let me go back to the vignette. Yeah, one of them is the job_loop function. So this is like, let's say you have, in this case, let's say we have 2 brain regions and we have 4 gene expression feature types that we want to loop through. And so what this does, job_loop, is that it creates a bash script that has 4 loops inside of it. And though once it loops through your variables, it's going to create, in this case, we have 2 unique regions and we have 4 unique feature expression levels. So it's going to create a combination, a file for each combination. So that's going to be 2 times 4 equals 8 scripts for you. And so this is something that I use quite a bit myself too. For if I have a master R script that can take a region input and let's say a feature input, and that will do a similar thing, but for each of the different types of inputs. And I just want to have a single master shell script instead of creating 8 of them myself manually and copy pasting and stuff. So this is like the script that will create the scripts type of thing. And so here's going to say like, okay, if you actually want to use this script, the way that you have to run it is with like sh and then the name of the script .sh. It's going to create the logs directory for you. And then it's going to say like, okay, we want to loop through region. That's the name we gave it here. The values are DLPFC and hippo. It translates that into the bash syntax. Then we want to loop through a feature, which is the name we gave for the second argument of our loops. And the values are gene, exon, transcript, and junction, right? Which are the inputs that we gave over here. And so it says like, okay, based on that, I'm going to create a specific job name for it. And that's also going to specify the script name. So this is going to be our prefix for the jobs. In this case, is like BSP2_test. And then we're going to loop through our variable that we're looping, region. So that's why we have here the $, and curly bracket syntax, and then we want to loop through feature. That will then create the script. So here we're we're writing to a script which is going to be hidden by default, and that's, you can do that using the a dot as the first value in the script name, and then .sh. So we're going to write to some. We're writing into that using bash syntax. So actually here now you can recognize some of the previous things that we've seen. So we see like being bash, current working directory, the memory, all of that. The name though, now the name is this variable that I'm calling it short. And so that also specifies the output and directory, sorry, the log files. But because we're writing a shell script that writes more shell scripts, now we actually have to escape all the shell variables that we want to run when we actually queue sub the command. So that's why now this adds all this like backslashes to the dollar signs that if I compare to what I have here on my right screen, I actually don't have any bash, I don't have any backslashes here on my job underscore single output. Okay, so it's going to loop through the files, it's going to create them. EOF stands for end of file. So that's the bash syntax for what we did here on the cat line. So we're writing into that script until the end of file. Here we're saying that's the end of the file. And then in our loop, we're saying like, okay, this is what you need to, this is what you actually need to run. qsub dot our temporary ID for the job .sh, or a temporary, like, I mean, for our internal like shell script is going to print the message, and then by default this will actually run qsub for you. Sometimes I comment out this line, the call line, just to see the messages are getting printed correctly. So this is a much more complicated script structure, and again, this was something that I've used a lot. I mean, I show you here like some of the origins of it on their supplement repository from like 4 or 5 years ago. And I would like copy paste it and then manually have to make sure that I edited all the variables, like make sure that I had all the environment variables that I wanted to use in my internal script escaped. Some of them are not escaped because, for example, this short one, this one is something that the main bash script is looping through. And so it's populating that and it's using it in that moment. These variables are only used, the user variable, job ID, all of those variables are only used later on when you qsub the job, right? Like this example here says like, okay, I'm gonna print the region, I'm gonna print the feature. And it's a fairly simple R script example it's not like, more advanced one could be like R script, let's say advanced.r region feature. So the way you can write this type of R scripts is using a different set of a different package called GetOps. GetOps. And so I have examples of those type of scripts, but I won't actually go through that type of syntax right now. Because I want to finish with sgejobs first. So, today. So those two functions, job underscore single, job underscore loop, are for creating files. Now, if you're doing this, and like in 2019, I was running a lot of like TWAS, you might get like, let's say you're running 50,000 jobs, right? And then some of them are inevitably going to fail. And so I would get like QStat output that looked like this, which was like, oh, my job ID 7706A3 failed, EQW. And so I wrote a little function here that a set of functions that can like look at output like this and then extract which are the IDs of the jobs that failed. And so let's say, oh, sorry, I didn't show the full output. So this was like, here I'm running like, the ones that failed were like from 225,001 to 225,007 in increments of 1. Then from 9 to 17 with increments of 2. Then 19 to 38 in increments of 1. So here I have like a ton of jobs that failed. And extracting the IDs for all of that is like quite a bit of work. So I wrote this function over here, Parsed Task Ids, that will like just identify like which are all the different components that failed. And so once I have all the jobs that failed, I can actually resubmit those jobs again. So the way I can do that is I can just use the arrays_submit function and pass to it the set of IDs that failed. So this was quite useful for me to resume. Let's say maybe this task over here failed because they were running on a particular compute node on the cluster that has some problems, or maybe they failed because those particular inputs require more memory than I had specified, or other reasons, other random reasons. And so this array_submit function, just what it does is that you have to specify to it a particular shell script. And what it does is that it goes into it, edits the line for each set of inputs, submits it, and then like it just goes through it. And then at the end, you can make it such that it restores the original state. And so this was quite useful for submitting a job. Now, also you're submitting array jobs. You'll notice at some point that the limit in JHPCE is for an array job is 75,000. And so I was actually running some array jobs, let's say for every X and X junction, and we might have around like 270,000. Or let's say I was running an array job for all the X's, and I might have like 400,000 of them. So that's more than the limit of 75,000. So using this, I made a companion function, array_submit_num, where you can be like, okay, I actually want to run this for 150,000 of them. And so what it does is that it uses the previous function, array_submit, and it finds the limits for you automatically. And it's like, okay, I want to run like the jobs 1 to 75,000 first, then 75,001 to 100,050 second, right? And so this is how you can create a bunch of files and submit them and resume. Now, if you're submitting a bunch of files, you're actually going to get a lot of log files yourself, but also the cluster creates a log file for each job ID and for each specific array task that you ran. And so, because you have a lot of log files, I wrote this function log_job ID that can read one of those log files. And if you're using the structure that I specified here, on the shell script, which prints here line 14 the job ID, it will look for a line of your log file that says job space ID, colon, a space, and then it will extract that number that you have. And so that's how I can get automatically the job ID for some files. And if I have those files, if I have those numbers, then I can go look at the JHPCE accounting files. This structure has changed over time. And so this example, I think I last ran in 2019. But because of that, you can then read those accounting files and you can extract information from them. So for example, this accounting underscore parse function will read those accounting files and just create a data frame for you with all that information. So SunGrid Engine keeps track of a ton of information. One of the variables, for example, is the max memory use, max vmem by your job. Another one is, where is it? Like this is status one, exit status. So 0 means that it actually ran correctly, and 1 means that it failed. I can see, like, for example, what user group I was running this under, what computer it ran on. So this is where I can identify, let's say I have 10 jobs that failed. I can like just check quickly what was the computer that they were running on. And if all of them failed because they were running, let's say like computer 51, then I can be like, hey, Mark, or I mean, hey, JHPCE admins, I think there's a problem with computer node 51, right? I mean, you can see like who ran it, in that case, this is me, etc. So this is useful because maybe you're running something, you're exploring how much time it takes, right? And so maybe you want to keep track of how much time it takes, how much memory each of the jobs take, right? And that way you can make some, nice summary plots. So those are the family of functions that SGE job has. So it has the parsing families, the parsing functions, the log related functions, functions for submitting jobs, for creating those shell scripts, and then actual functions for submitting like array jobs with a set of like task ids and stuff like that, and the accounting functions. So that's what this package is mainly about. So it only does a couple of things. It doesn't do everything, right? There's, for example, another package that John Muscelli made. I think it's, yeah, I have here on the conclusion set of the vignette. This is another package that John Muscelli made that was useful, for example, if you wanted to extract information about who's using the cluster, right? And so like right now, for example, that is really busy, I could use that package to try to figure out if there's like, I don't know, let's say, let's say Andrew's running like a bunch of stuff in the cluster, right? I can be like, hey, Andrew, you're killing us, type of thing, right? So that's, what this cluster rundown other package does. So, yeah, so SGE jobs, I find it really useful for me because it minimizes the amount of times I need to copy paste stuff, and it has this templates that like bash script templates that include all the reproducibility information that I've had to use over the years for debugging and jobs on the cluster at different times. It doesn't do like all this like, let's create an R script like test.r that takes inputs and all that. That's a separate, you still have to do that manually outside of SGE jobs. But it will get you, half of the way there. And for most of you, I think you just need to use like job underscore single. That's really like the main function you might be using for a lot of the things you guys are doing. But there might be a scenario where you're running array jobs and stuff like that, and then at that point it can be useful to use these functions here. Cool. So yeah, I thought that it would be useful to talk about the software that we've made at Liber. that could be used by you for your own work. And so this is one of the packages that we have, one of our GitHub packages. Okay, so with that, I want to stop recording.